Hello guys, this is the second part of Formulas in 3D video. We will be talking about how to find diagonal of right rectangular prism, how to find distance between 2 points and midpoint of 2 points in three-dimensional figures. So the first part, diagonal of right rectangular prism. Um, it turns out that if we look at the rectangular prism, we actually consider the diagonal inside that rectangular prism. When you look at the given figure, the diagonal can be drawn from one vertex to diagonally opposite vertex. So we're going to find the length of this diagonal. So the formula of diagonal is given by squares of square root of squares of all dimensions. So it is square root of length squared plus width squared plus height squared. The height is given, length is given, width is given. So when we square all of them under the radical and add them up, we'll get the diagonal. You'll face two types of questions here. You will be either given all dimensions and asked about the diagonal, or you will be given only two of the dimensions along with diagonal. The one dimension will be the missing. So let's try both. The first question we're gonna look at is 5, exercise 5 in your book. Exercise 5. It's asking about diagonal. We are given the dimensions as 4, 8, and 12. And it says find the unknown dimension in each figure rounded to the nearest tenth. So diagonal formula, apply diagonal formula equals square root of sum of squares of dimensions, which are 4 squared plus 8 squared plus 12 squared. What do we have? 4 squared is 16, 8 squared is 64, 12 squared is 144. When you add them up, you'll get 224. 224. Type it into your calculator. It will give you 14.96. And the question is asking about rounding it to the nearest tenth. So it's approximately 14.9 is approximately 15. So our diagonal is 15. The unit is given by centimeter. 15 centimeter. Okay, it's pretty easy. What about 6? In 6, we are not given the height. Height is missing. We are given dimensions, width and length, and we are also given the diagonal. So this time diagonal is not missing, height is missing. So replace what's given back into the formula. In place of diagonal, we're gonna write 13. So 13 equals square root of length squared, 6 or 10, it doesn't matter, we are squaring them anyway, plus width squared, 10 squared, or the opposite, plus the height is missing, 8 squared. So this is the equation you should set up first. We need h alone. H is under radical, so the only way to get h is getting rid of the square root symbol. How do you get rid of the square root symbol? By squaring both sides, right? So when you square both sides, the radical will lift off. So on the left, you'll have 13 squared, which is 113, 169, 169. On the right, you'll have 6 squared, which is 36, plus 10 squared, which is 100, plus 8 squared, and 100 plus 36, 136, and you bring 136 to the other side. 169 minus 136 makes 33. 33 is 8 squared. What you need is h, not h squared. So get rid of the square here. How do you get rid of the square? By taking the square root of both sides. Take square root of both sides. The radical will lift off. On the right, you'll have h. On the left, you'll have square root of 33. What is square root of 33? Use your calculator. It will round it. It will give you an approximate result. It is equal to approximately, when you round it to the nearest tenth, it's going to be 5.7. The unit given in the question is centimeter. So your height of this rectangular prism is 5.7 centimeter. Formulas we're going to talk about are distance and midpoint formulas in 3 dimensions. It's pretty easy. We also talked about distance and midpoint formulas in 2D. Many of the results that we know for 2D plane carry over to the 3D space. So if we know the formulas, distance and midpoint formulas in 2D, we just know that we have an extra dimension here, z. So we're just going to add z's here. The midpoint formula is you take the average of each of the coordinates. What does average mean? You add the x's up, divide by 2, add y's up, divide by 2, add z's up, and divide by 2. So this is the average. Average of x's is x1 plus x2 over 2. Average of y's is y2 plus y1 over 2. Average of z's is z1 plus z2 over 2. This is your midpoint. To find the distance between 3 points, you take square root of differences of x's, y's, and z's. Squares of differences of x's, y's, and z's on the radical. Let's take a look at the question. Let's try exercise 13 here. The others are easier. 13 is better to solve. To find distance in 13, apply the formula. The formula is square root of squares of differences of x's, y's, and z's all summed together. Square root of differences of x's, squares of differences of x's. Your x's are 4 and 9. You can write x1, y1, z1 here, x2, y2, z2 here. Order doesn't matter. You can switch the points order. What matters is the order of the coordinates. So first x coordinates, second y, third z coordinates. So subtract x's, 9 minus 4 squared, plus subtract y's, 12 minus 6, and subtract z's, 15 minus 10. So you are squaring differences of all coordinates on the radical. This is how you get distance between 3 points. It's equal to 9 minus 4, 5 squared, 25. 12 minus 6, 6 squared, 36. 15 minus 5, 5 squared, 25 on the radical. When you add them up, you'll get 86. Square root of 86 is 9.27, which is approximately 9.3. That is the distance between 3 points. What about the midpoint? Apply the formula. Take average of each coordinate. Average of x's, x1 plus x2 over 2. x1 is 4. x2 is 9. 4 plus 9 over 2, comma. Take average of y's. Your y's are 6 and 12. 6 plus 12 over 2, comma. Your z's are 10 and 15. 10 plus 15 over 2. 4 plus 9, 13. 13 over 2, 6.5. 6 plus 12, 18. 18 over 2, 9, comma. 10 plus 15, 25. 25 over 2 is 12.5. So this is your midpoint.